This video is on electrolytes and non-electrolytes. So first, let's write the definitions. An electrolyte is a substance whose aqueous solutions contain ions. And therefore, because they contain ions, they conduct electricity. So they have all these ions moving around, and so electricity can flow through them. A non-electrolyte is a substance that does not form ions in solution. And therefore does not conduct electricity. So let me show you a little bit more what I mean with some diagrams. All right, so here's my electrolyte. All right, so something like sodium chloride, so table salt, is an electrolyte if it is aqueous. So what it does is it dissociates, which we're going to write down in a minute. But what you'll see is sodium chloride as an aqueous solution will separate into the ions of sodium and chloride. So if I have a solution here of aqueous sodium chloride, remember that's going to be sodium chloride dissolved in water. What we're going to see is, right, so this is my water. That's what makes it aqueous. And what will actually happen is, and you won't actually see this obviously, is you're going to have all these little sodium ions floating around and all these little chloride ions floating around. And because you have those charges, electricity can flow. So what can happen is, let's say I have a battery over here, and let's say I have a light bulb over here. And I use wires and I connect them to this, and this, and then to each other. I'd have a complete circuit because the electricity will flow through the solution that has ions in it. So you'll actually see, right, the light bulb light up due to the voltage from the battery. So on the flip side over here, let's say I have a non-electrolyte. Something like glucose, C6H12O6. Okay, even if it's aqueous, so just like the other one, got our water here, and you know sugar dissolves in water, but it will not separate into ions. All you're going to have are these little molecules of sugar. So if I set up the same situation with a battery and a light bulb, and I hook them up with wires, same as the other situation, no electricity will flow because we don't have any ions, any charges in our solution for the current to go through. So this, nothing. All right, so what kinds of things are electrolytes? What kinds of things aren't electrolytes? And then what do they do? So remember, ionic compounds are made of a metal plus a nonmetal. And metals have a positive charge and nonmetals have a negative charge. That's ions. So when an ionic solid dissolves in water, like sodium chloride in the example above, the ions pull apart. Or the actual term for that is dissociate. And you might also hear the term ionize. So they essentially separate into their ions. All right, so a couple examples. Potassium chloride, KCl, aqueous solution. This is an ionic compound. Potassium's our metal, chlorine is our nonmetal. So what you'll get here is you'll get something that dissociates into positive potassium and negative chloride. And notice they're all still aqueous because they all still have to be dissolved in water. So another example, sodium sulfate. So sodium is my metal, and it's a +1 charge. But notice how it's Na2. So that means I have 2 sodium ions for every 1 sulfate ion. And remember, a sulfate ion is a -2 charge. So our atoms and our charges are all balanced. All right, and then one more here, aluminum nitrate. So this would dissociate into aluminum, which is a +3 charge. And I have 3 nitrates, each of them with a -1 charge. So these are called dissociation equations. All right. So now what kinds of things, let's go over here, are non-electrolytes? And these are going to be our molecular compounds. So these are typically things that are nonpolar, okay, or things that aren't ions. So most molecules do not ionize when in solution, and therefore are considered non-electrolytes. Like the example I had of sugar. So pretty much all sugars. So sugar like glucose. Actually, I'm not going to use an arrow there. Okay, like glucose, there's sucrose, fructose, dextrose, all kinds of sugars. So we had this example. Other examples are things like alcohols. So anything with a hydroxide group at the end, like methanol, CH3OH. These would not ionize, so they would be the non-electrolyte example. All right, there are a couple exceptions to molecular compounds ionizing. Things like acids and bases, so acids like HCl. So hydrogen can be a cation, so this would ionize, so this would actually give you, right, HCl in aqueous solution would actually dissociate into hydrogen with a plus charge and chlorine with a minus charge. Or some bases like NH3, and this is ammonia. And when we write NH3, to show this equation, it's still aqueous, but to show what actually happens, and we'll discuss this more and understand more why later, but I'm going to actually write the water as a reactant so that what we get is we get NH4 plus, so we get that ammonium ion, and we get hydroxide anions. All right, so that is kind of the basics of electrolytes and non-electrolytes.